Everybody, hopefully you're doing well today. Sorry I'm not here, but we'll get through the lesson anyhow, and you can go forward with where you're at, and we don't have to slow down for any reason. Hopefully your ray diagrams went well last night. I did put the key up, and so hopefully you checked your answers, and hopefully it made sense. If not, let's pick that up on Wednesday, and we can also go over the mathematics of curved waves in the mirror and magnification formulas and things like that. So if you have any questions, let's talk about it on Wednesday. Shoot me an email, maybe tomorrow night, or I guess for you that would be tonight. Shoot me an email, or we can just talk about it on Wednesday. We'll see about the quiz. We'll see what happens with that. I really don't want you to have 4 or 5 days without anything as far as physics goes, but we'll see what happens. All right, so no stress. Don't worry. Things will work out. I'm not going to make you set you up for failure. So we'll go forward. So let's talk about first the formula for the mirror formula as well as magnification. All right, because that's really what mirrors are doing. All right, and we did the ray diagrams, and now we're getting into the mathematics behind that as well. So the basic formula is this. You have 1 over your focal length is going to equal 1 over the distance of your object plus the distance of your image. Okay. So again, F is your focal length. Your distance of your object. All right, so this will be distance from mirror, because remember we said that all the distances are always from the mirror. So this is no different. Your distance from the mirror to the object, And your distance image is going to be the same. You're going to have your distance from the mirror once again, because every distance is from the mirror to the image. All right, there you go, image. Let me spell. So that's your basic formula. It doesn't get any harder than that. Just plug it in numbers, things along those lines. Since I'm here giving you formulas, let's go ahead and knock out the magnification formula, because we'll use both in the problem that we go with. All right. So magnification is M. Magnification is M. And M is pretty easy to find. We have the height of our image over the height of our object. Or if you have troubles finding that, this is also the same thing as the distance of your image over the distance of your object. And notice here I put this pesky negative sign. It's going to mess us up a couple times, but we just need to watch for that and see what's going on. But this is your formula for magnification. All right, we'll start there. So again, your height of your image, H-E-I-G-H-T, image height or object height. All right, so there's your variables defined for you in right fashion. All right, so there's that. I want to do number 1 with you just because I thought it was a good place to start. So Bobby is placing a 4.25 centimeter tall light bulb a distance of 36.2 centimeters from a concave mirror. If the mirror has a focal length of 19.2 centimeters, then what is the image height and the image distance? Okay, so first things first, let's go ahead and start with writing down our formula just to make sure that we know what we're dealing with here. Okay, so we have our formula written down there, and let's go ahead and define our variables too. It gave us an object height of 4.25 centimeters, so that's pretty easy. It gave us an object distance, so distance from the mirror at 36.2 centimeters, and it gave us a focal length of 19.2 centimeters. All right, there's our formula, there's the variables that we have to work with, and since we need to find the image height and the image distance, I'm just going to go ahead and start with finding the image distance, because with that we have two of the variables already, and that'll be pretty easy to find. So just taking our formula, plugging in our numbers. There we go. There's a couple ways you can go about doing this. You could just knock yourself out and solve for your image distance, and that's fine if you want to do it that way. Personally, what I find a little easier is to go ahead and convert these to decimals. So if you convert these to decimals, you have this, and then you have, what is that, 0.0276 centimeters plus your distance image. There you go. And you can just solve from here, okay? So minus 276 minus 0.0276 centimeters. And so when you subtract those out, hopefully you get what I get, somewhere in this neighborhood. And this, again, is going to equal your distance image. And from here we can just solve. Just if you want to do the old-fashioned solve, or you just notice what you're going to end up doing and finding the reciprocal of that is really what you're going to end up doing. So you're going to have your distance image over 0.0244 centimeters. All I did was multiply this by both sides and then divide this out, and so that's what you end up with. And you're going to, once you hit that up, you will get 40.98 centimeters as your image distance, or your distance to the image from the mirror. Okay, so that's one of our answers right there. Our next answer is we're looking for the height of the image. So we're going to have to work with the magnification, hence why I gave you the magnification formula already. That you have your magnification, okay, writing out the formula. And again, remember I said that and it's going to mess you up a bit, that you have that negative sign there, but it'll work out in the end. And you'll see why in a couple cases, why this actually is, because once you get into the virtual images, this will become a positive number, at which case you're going to have a larger object. Okay, so this is partly why that's negative there. But filling in for here, solving for magnification first, that you're going to take your 40.98 as your image distance, and again, that's going to be negative, so negative 40.98 centimeters over your distance to the object, which was 36.2 centimeters. Once you solve for that, your magnification in this case is going to have a negative 1.13 will be your magnification. Notice your centimeters are going to end up canceling out, so you're not going to have a unit for magnification. All right. Once you get that, this is what you can do. You can then remember that magnification was this, but magnification is also equal to what? Yes, that's right. It's going to be your image height over your object height. Okay, so here's our magnification at, we'll just set this up for you just so we don't lose anybody. So negative 0.13 is going to equal, we have our object height, which is 4.25 centimeters, and you have your image height is what we're going to end up finding. Okay, so once you multiply, of course, that, and you're going to have a 4.25 times 1.13. Type it in the calculator. Image height is going to be what? Negative 4.8 centimeters. All right, so you see that it's going to end up to be inverted. All right, so there you have it. That's how you do number one on the mathematics of curved mirrors. We use the mirror formula. We use the magnification formula, all right, to solve for each of those. And that's as hard as the math gets, all right? You're just having to find the reciprocal of things, or if you just wanted to go ahead and knock it out and solve for your variable. Totally up to you. Either is fine. Like I said, this is pretty much as hard as the math gets, and so hopefully it goes well for you. And like I said, we'll talk about it on Wednesday if there's any confusions. All right, have a good one.